Hello friends, in this video we'll see the topic number system. We'll start with real numbers. We know that real numbers are the numbers that lie on the number line. Number line looks like this. Number line contains numbers 1, 2, 3, 4, 5 and so on. Number line also contains 0. Generally we write 0 at the center of the number line. Number line also contains negative numbers which are -1, -2, -3, -4, -5 and so on. We know that what is the set of natural numbers? Set of natural number contains numbers 1, 2, 3, 4, 5 and so on. And we can easily observe that all these natural numbers lie on the number line. If we include 0 in natural numbers, we get whole numbers and we can see that all whole numbers are also lie on the number line. If we include -1, -2, -3, -4, -5, and so on in whole numbers, we get a set of integers, and all integers are also lie on the number line. Set of integer is also expressed as set whose elements are 0, 1, -1, 2, -2, 3, -3, and so on. Because in set, order of elements is not important and it does not matter. One can say that the elements of set of natural numbers, whole numbers, and set of integers we can count. Means 1 is the first natural number, 2 is the second natural number, 3 is the third natural number, 4 is the fourth natural number, and 5 is the fifth natural number, and so on. 0 is the first whole number, 1 is the second whole number, 2 is the third whole number, 3 is the fourth whole number, 5 is the fifth whole number, 5 is the sixth whole number, and so on. In set of integers, we can see that 0 is the first integer, 1 is the second integer, -1 is third integer, 2 is the fourth integer, -2 is fifth integer, and so on. Means we can count the elements of sets of natural numbers, whole numbers, and integers. Means we can see that we can count the elements of these sets. The counting will not stop. That is another fact. But we can count the elements of natural numbers, whole numbers, and integers. So we can see that these sets are countable sets. See, the set of the number line also contains numbers other than natural numbers, whole numbers, and integers. For example, 1 by 2 lie on the number line whose value is 0.5. 3 by 2 also lie on the number line whose value is 1.5. 5 by 2 also lie on number line whose value is 2.5. Similarly, 7 by 2, 9 by 2, -1 by 2, -3 by 2, -5 by 2, -7 by 2, 9, -9 by 2. See, 1 by 3 also lie on the number line whose approximate value is 0.33. Similarly, -1 by 3 is also there on the number line. 2 by 3 lies on the number line whose approximate value is 0.66. Similarly, -2 by 3 is also there on the number line. Root 2, whose approximate value is 1.4142, also lie on the number line. Similarly, minus root 2 also lie on the number line. Root 3, whose approximate value is 1.7320, also lie on the number line. Similarly, minus root 3 is there. Pi, whose approximate value is 3.1415, lie on the number line. Similarly, minus pi is also there. The real number e, whose approximate value is 2.7182, also lie on the number line. Similarly, minus is there. We know that the set of rational numbers. Set of rational number contain all the numbers in the form of p by q, where p and q are integers and q is non-zero. You can see that the numbers 1 by 2, 3 by 2, 5 by 2, similarly -3 by 2, -5 by 2, 1 by 3, -1 by 3, 2 by 3, -2 by 3, all are rational numbers and that lie on number line. In fact, if you take any number p by q, where p and q are integers and q is non-zero, that we can show on the number line. Means each rational number lie on the number line. And this number line also contains the numbers we cannot express in the form of p by q, where p and q are integers and q is non-zero, and these numbers are called as irrational numbers. Means if you remove all the numbers from set of real numbers, if you remove all the numbers we can express in the form of p by q from set of real numbers, we get a set, that is set of irrational numbers. Means set of irrational number contains all the real numbers, means all the numbers on the number line which cannot express in the form of p by q. Means root 2 minus root 2, root 3 minus root 3, pi minus pi, e minus e, all are irrational numbers because we cannot express these numbers in the form of p by q, where p and q are integers and q is non-zero. One can observe that q is countable set, means we can count the elements of set of rational numbers, but the set of irrational numbers q complement is uncountable, means we cannot even count the elements of set of irrational numbers. In standard books of real analysis or calculus, you can see the proofs of this result. Q is countable set and q complement is uncountable set. Friends, I am stopping here. Thank you for watching the video.